Hi, I'm Alex Cheong.
I'm Conor Neufeld.
And I'm Abby Barnes.
And this is teaching t-test in AP Statistics.
Before we go into detail, let's go over the basics. A t-test is used to find S, which we use when we don't know the standard deviation of a population. This S can then be used in equations to find the standard error, t-statistic, which is the significance level, and confidence intervals of 1 and 2 variable statistics.
Now here are some variables for one sample statistics. Standard error is S divided by the square root of n. The t-test is the sample mean minus the mu over S divided by the square root of n. And a confidence interval is the sample mean plus minus t star times the quantity of S over square root of n.
So this is what you need to know for two sample statistics. First off, you need standard error, which is the square root of S1 squared divided by N1 plus S2 squared divided by N2. Now you'll be using this in your t-test, which will consist of t equaling sample mean 1 minus sample mean 2 divided by your standard error. Your confidence interval will be consisting of sample mean 1 minus sample mean 2 plus or minus t star times your standard error. Now, you'll be using these confidence intervals when testing out your different hypotheses.
The first thing you'll need to know when you want to carry out a t-test is the sample's degrees of freedom, which can be found using the formula n minus 1, where n is the sample size. If you look in the back of the book, The Practice of Statistics, to Table C, you will see the degrees of freedom column on the far left side of the page. We then use the rows on the top and bottom of the page to determine the S value for a particular equation. If, for example, we wanted to find a 95% confidence interval of 20 observations, we would find the degrees of freedom column on the left side of the page where it equals 19. Then we would go to the bottom of the page and find the 95% interval. Where they intersect is our S value. Here it is 2.093.
Okay, now to explain a one sample t-test, we're going to use exercise 11.13 off of page 633 from The Practice of Statistics. It is about a Spanish teacher's workshop. The National Endowment for the Humanities sponsors summer institutes to improve the skills of high school language teachers. One institute hosted 20 Spanish teachers for 4 weeks. At the beginning of the standing period, the teachers took the Modern Language Association's listening test of understanding of spoken Spanish. After 4 weeks of immersion in Spanish in and out of class, they took the listening test again. The actual spoken Spanish in the two tests was different, so simply taking the first test would not improve the score on the second test. Table 11.4 gives the pre-test and post-test scores. The maximum possible score on the test is 36. So now what we have here is all the differences of the post-test and pre-test. We put that into the calculator, and this data we get is the sample mean is 1.45, standard deviation is 3.122, and our end population is 20. Now, our null hypothesis states that there is no change whatsoever, with mu equaling to 0. Now, our alternative hypothesis states that there is a change, with mu greater than 0. Now, here we need to check that our data is roughly normal. Here you can see that it's slightly skewed to the left, but it won't affect our t-test. For test of significance, we use a calculator to find S, and the way we find S is with the data in our calculator. We enter into a one variable statistic, and our S comes out as S of X in our graphing calculators. So what we have here is our S value is equal to 3.20. So we have this equation, and we plug in all the numbers. 1.45 is our sample mean. Since we're testing for change, where our mu is going to be 0. So we then plug in our S value of 3.20, and our population is 20, so plug that right in there, square root of 20. And our t value we get is 2.026. Now this means that there is significant evidence at the 0.025 level, but not at the 0.05 level, to reject the null hypothesis. Now for our data, we need to find a 90% confidence interval. The way we find that is with our t-star, we go to 19 degrees of freedom on our t-table and up to the 90% confidence interval, which will give us the number 1.729. Now when we run it through for a confidence interval, we use this formula. Then we plug in these numbers, which is a sample mean of 1.45 plus minus our t-star of 1.729 times the quantity of 3.20, which we got in our previous S value, over the population of 20 and under a square root. With that, we get this interval of what this all means is we can be 90% certain that for 20 test takers, both pre-test and post-test, we get an average improvement of 0.213 to 2.687 points.
For two-sample statistics, we have two different means, two different SRSs. Both distributions must be normal and they must be independent. The hypotheses will always compare one mean to the other, but not to numbers. Now let's do the exercise 11.39 from page 657 in the Practice of Statistics book. The Chaplin Social Insight Test is a psychological test designed to measure how accurately a person appraises other people. The possible scores on a test range from 0 to 41. During the development of the Chaplin test, it was given to several different groups of people. Here are the results for males and female college students majoring in the liberal arts. Using the formula, we are going to plug in the mean of the males first, and then subtracting with the mean of the females. We'll then divide it by the square root of the S of the males divided by their population, plus the S of the females squared divided by their population. With that, we'll be then given the t value of 0.6537. Now that we have our t, now we'll go into table C in the back of the Practice of Statistics books. We'll first find a degree of freedom, which will be the lowest of the two populations. For this example, it will be 132. Now, because the degree of freedom in table C does not have a 132, we'll automatically go to the 100 degrees of freedom. We'll then look for our number among the probabilities. Now, since our t statistics is smaller than any of the numbers given on the table for that degrees of freedom, 100, we can automatically assume that the probability is much greater than any of the critical levels on table C. This means that we do not have enough evidence to reject the null hypothesis at any given level. While the example or the problem doesn't ask really for any confidence interval, we're going to do one just for the sake of this video. We're going to be doing a 90% confidence interval for this problem, and so this is the equation we'll be using. Now, we'll find our t star. To do that, we'll go into the back of the book in table C. Using the degrees of freedom from earlier, 100, we're going to look up 90% confidence level, and we'll find our t star, which is 1.66. Plugging this equation into our graphing calculators, we ended up getting the numbers negative 0.6158 and 1.4158. These numbers represent to us that we are 90% confident that the difference between the means are between these two numbers.
I hope this review has given you a better understanding of the t-test in AP Statistics. Thanks for watching!